So continuing on, we have page 9. Probably should take note of pages before I actually start a video, but here we are. AE bisects BAC. So it's a nice easy one that we're starting to get used to. Got to state the given, which is annoying. It'll never not be. And I can also state, because it's easy enough to account for here, A, B, and AC are congruent. All right, so this will be a reasonably short proof because I have good old reflexive property to fall back on. I know that AD is congruent to itself. Now, they named angles ABD and ADC, I'm sorry, ADB and ADC as angles 1 and 2 in the diagram, so we could rely on that. We don't have to make a statement for that. If you ever wanted to designate an angle numerically, you'd have to make a statement of equivalence. You'd have to state, let angle blah, blah, blah be equal to 1, angle blah, blah, blah be equal to 2. They already did it for us, so we're good. All right. So what I can now state, based off of this information, I get a side, another side, and an angle sandwiched in between those two sides. So, and again, S, A, followed by an S, in that order. We're looking at the SAS axiom. All right, so the triangle CAD congruent to triangle BAD. All right. So here's another Easter egg for somebody, another bonus point opportunity. This next rule, justifying that angle 1 and angle 2 are congruent, I call that, or it is called CPCTC. But in my last video, I referred to it by another name. So the first person who sends me a message indicating that they know the name for that, what I referred to it as, the blank rule, what is, fill in the blank, I'll give you a bonus point. All right, obviously this only works for my students, so we'll see who gets it first. Number 2, IH is parallel to LK, so I'm just going to jot that in. Oop, that's not a K. IL bisects HK. Both given. So IH is parallel. It doesn't say anything about congruence, so I'm going to leave that alone for a sec. But IL bisects HK. So IL is the knife that cuts HK into congruent pieces. So that's where I will start. So HJ is going to be congruent to KJ. Definition of bisector. I'll be a little bit more specific. Segment bisector. All right. So I now know that at least one pair of corresponding sides are congruent. I also know that we have these two bad boys. They're going to be congruent. It has nothing to do with the given. Let me change the color on that. Let me go green for those keeping score at home. All right, so IJH angle IJH, and angle LJK, or vertical. Definition of vertical angles. A little schmutz there, I keep doing that. Then I could also state that those angles are congruent. Looks like ish. IJH congruent to angle LJK. Vertical angles are congruent. That's not an angle symbol. Jeez Louise. Are congruent. It's a whole brain processing in a different way from hand movements and so on. All right, so I need something else. Well, I do know that I have two parallel lines. And I also know that if two parallel lines are cut by a transversal, like for example this line, then the alternate interior angles would be congruent. Oh, hello. So I got that. Now my issue is I went crazy highlighting things. I can't see anything anymore. So let me just erase some stuff. At least make out what I need to make out. But now I have something. I got something to work with. So I'm going to say angle HIJ is congruent to angle KLJ. And there's really no way around it. I mean, people have come up with different shortcuts for this over the years, but none of them are really that good. Or not as good as just writing it out. If two parallel lines are cut by a transversal, the alternate interior angles are congruent. All right, because people, you know, they'll write things like alternate interior angles are congruent. Well, alternate interior of what? You know, it's fine that you know some vocabulary. It's just if you don't know what it means. You know, this isn't like what I was talking about before with CPCTC. You know, if you know when to use that abbreviation, I'm pretty confident that you at least know what most of the letters in the abbreviation represent. But if you just say alternate interior angles are congruent, how do I even know that you're talking about parallel lines, you know? So now there is the, you know, the counter argument like, well, dude, if I'm using it in this context, obviously I know what it means. Yeah, but you got to give me a little bit more. All right, get the words parallel lines in there. Get the word transversal in there. All right, if you do that and also address the alternate interior angles being congruent, then you'll be meeting the standard. Right, which is great, but then it begs the question, well, why not just write the whole thing? All right. So it's kind of like if you're solving a problem and somebody says, you know, you solve for X and round your answer to 8 decimal places, and the calculator gives you 9 decimal places. Like, well, why don't I just write the last digit? You know, like I got to write the whole thing anyway. You know, so that's part of it. Or at least in my thinking, in my mind, which is a magical place. So anyway, I'm going to state now that the triangles are going to be congruent, HIJ, congruent to triangle KLJ, and this is by two angles with not one side that's not included in between, so angle, angle, side, axiom. Now, IJ and LJ are two sides that are contained, corresponding sides, that are contained within those two congruent triangles. So I now know that IJ is congruent to LJ by corresponding parts of congruent triangles are congruent. And there it is.